Hey guys, what's up? Hope everybody's doing good. I'm gonna give you guys a little bit of an update on what's been going on with the space weather and other things that's been going on here too. So, um, yeah, definitely gonna do that. So, give me 1 second, guys. I'm still kind of setting up. But thank you guys for stopping through and checking me out here. And anybody that came over to the lifeboat tonight, thank you. I would appreciate it if everybody could actually just check that channel out. Also, it's called The Lifeboat. It's an addiction recovery channel. Me and my partner Tommy over there, we run that channel, and it's a big family. I've talked about it multiple times. We had a really good show tonight. A lot of people showed up, and it was a really good topic. Disconnect or connect is the key to, basically happiness. You got to do one or the other, or do both. And it was just a really good conversation tonight. So if you guys would, please go check that out. Yeah, we're going to go ahead and do the space weather thing. Okay. But as you can see, guys, they're still forecasting a G1 storm. Um, you know, this event that we've been talking about, for about a week now, these CMEs did impact us, and I'm going to show them to you here in just a second. They didn't hit as hard as they could have. But and I mentioned that, guys. If you guys remember, I want everybody to be on top of it and understand that sometimes we just don't know the strength of these things and how our magnetic field's going to handle them. And there's reasons why we didn't get into major storm levels, and we're going to go into that. We did get into storm level though. I actually talked about that a bit, and but so you got a G1 storm predicted for tomorrow. Well, here in the next few hours. And we are starting to see a little bit of an increase in space weather right now. We've also had a few more flares. Now, the flare that was causing all the issues before is now rotated off. Let me show it to you real quick while I'm talking about it, huh? Probably be the best thing to do, you think? Okay, so if we're going to look at this flare, it's right here now. Okay, now there's a few other things going on here. And we'll talk about that too. But as far as overall X-ray production from the sun is really has dropped significantly, and probably the biggest reason is the sunspot is no longer really facing us. It's over here on the limb. So, and it's still flaring. Okay, just so you know, it's erupting still. That sunspot is not stopping. So, and we've seen these sunspots actually rotate to the backside and then come right back around to the front and still be very active and very powerful and really, affect things here. But as you can see, guys, that's on the limb now. So what I'm going to do, actually, I'm just going to grab that like that. So you can still see it flaring, but you can also see that it's now way over here. It is actually behind the limb now. Now, there's still some X-rays sneaking by there because it hasn't rotated all the way off. But you can see it's still erupted. See that? But that ain't the only game in town, guys. Okay? This one here isn't huge right now, but it's flaring. Okay? Right there. See that? And it's erupting. Okay, I'm not sure if a lot of it is actually the plasma leaving the sun on that one yet, because that one actually just happened, that flare there. But there's other sunspots going on, and this thing is now erupting multiple times. So, and I think this is what we're going to start seeing. We're going to start seeing all these sunspots here as we progress on into the sun cycle. They're going to become more and more complex because there's just going to be more of them. So obviously, the chances of them being complex rises, right? So if there's more sunspots, there's a chance that one of them is going to be pretty complex, if not multiple, and that's what causes them to fire off flares, and the flares can instigate CMEs. So that's that's what we keep an eye on. But I have to say, looking at the sun right now, it doesn't nowhere near look like it did a week ago. You can definitely tell that it's not firing off right now a whole lot, except for that one right there. Now, the other sunspots are doing little small flares. And so we'll go back over here. And So you can see them, right? Now, remember when this event kind of started, the baseline, I talked about this, the baseline was almost in the C range, right? C class flare. So if you like put that into what's happening right now, if you were to take this, basically a baseline of X-ray production, and move it up here, guess what? This C flare right here now becomes an M flare. Okay, so that's the reason we even consider talking about the baseline here on X-ray, because it doesn't take such a bigger flare to actually put you up into M class or even X class flare if the baseline is low. Sorry guys, had to take, my mouth was just like really dry. I'm sick also. I'm not going to go into that part of it though. Been running a fever. My wife's been extremely sick. My partner Tommy, he says, you know, you ain't got a fever. you got a radio station, 103.5. Come listen to the fever. You know, that kind of thing. That's hysterical. I'd never heard that before until he said that to me about, I don't know, 8 months ago. Because when I get fevers, guys, you guys have heard me talk about it. I don't get no stinking 99.4 or something. I go straight from, you know, being okay to 102 or 100, even sometimes 104. But that's just what it is, guys. Just what it is. Okay. Oh, really, Raven? That sucks. Prayers for you. Yeah. Yeah, it's a high fever rate and stuff. I don't have like 104 right now. It is in the hundreds right now, but it definitely, and it's nighttime where I live, you guys. So, and if anybody don't understand that either, there is a lot of studies and a lot of, well, it's just kind of common knowledge among doctors and even most of us. Nighttime, your fevers will get higher. For whatever reason, our biology does that. I don't know why, but I don't know the science behind it, but it does. So anyway, guys, you see this up and down right here? Those are CME impacts. Okay? Notice that they dove off, come back up, dove off, come back up. Just like skirting with storm level. I mean, and if you were to go look at like the 30-minute, because you can do this, you can go down to like a 30-minute time lapse here, and you'll see that we actually would bump up into storm level but come back down really quick. So what that means is these are 3-hour averages. So they take the 3-hour average of X-ray product or geomagnetic activity, KP index here, and that's what they plot. Now we snuck up into storm level. Now when we were actually in storm level, when we had like a G2 going on, we really at different points in time during that event, we actually snuck up into G3 for not an extended amount of time, but we did get there for a minute. Okay, so yeah, that's happening. But you see this, and I have to say, our magnetic field really did handle this fairly well. Also, that, you know, I was talking to you guys about the direction of these CMEs that we're hitting. And let me just refresh that real quick. Remember me talking about how I said they look like they might be sailing a little bit south of us sometimes? And that's exactly what's happened. Okay? We didn't take the direction of them that we thought they were coming was a little bit tilted to the south. And we knew that it was tilted to the south, or the direction of it, general direction. But we didn't know exactly how far south, so we were all questioning it. And we talked about it here. If we were going to get glancing blows or a direct hit. And we did get one direct hit from like that initial one. But the other ones that came after were more so a glancing blow to our south. Now, I'm using that as a blanket statement because I'm not going to get into details on that because it would bore people. It would be word salad. So, and I'm not going to do that. But you can see that the sun is still doing things. See that? Now, I find this one a little interesting because that is from that sunspot that we were talking about. And remember, I said it was like almost has already been over here on the limb and now is actually kind of on the backside but this is the time frame here is, if you look at this yellow line, I'll move it forward to here. That's where we're at right now, roughly. Okay, because this gives us 2 days behind us. Notice what's happening here. Okay, there's some other CMEs going on here. This is right now. So whatever fired off the sun a couple days ago, right there. Okay, which would be that sunspot I was telling you is off the limb, would be actually still facing us somewhat. But you can see how this thing fires off, and this is actually showing you that this is still taking a southerly direction. So whether or not, again, that if this one hits, now they're saying it's going to. Okay, you're seeing a 15 on the density up here. You see this up here? And then you see the speed actually increases also. Whether that materializes or not, we're going to have to wait and see. And see how, strong it actually is. Now, you can kind of tell how it kind of split here, too. I didn't see 2 separate eruptions. It doesn't mean that there wasn't. But I didn't see it. But now you can tell how, the density is kind of split in half there. But even this one here, guys, it's sailing to the south. So, but it does look like we're going to take a glancing blow from that, which is probably why they are saying G1 storm on the 22nd. Okay, that's probably why. I'm just guessing, I guess. But yeah, so yeah, that's what happened there. Now, what can we expect and what's going on now? What did happen with the G1? Well, let me show you guys something. And I'm not going to show this very long because I want you guys, again, to go give these guys some love. This is spaceweather.com, guys. These guys are awesome. They just do a really good job. Oh, sorry, guys. I didn't mean to do that to you. Hold on, let me get back to... Yeah, I never say this here either, guys. Can you guys give me a like and share this out, if you would? It really does help. That's the best way you can support me if you want to do that. That'd be awesome. I don't monetize or anything like that, so the best way to support me and my channel here would be to share it out and hit the like. I would love it if you guys would do that. Marth and anybody else that's helped build my channel. Yeah. Outside of that, the best way to grow the channel is to get you guys to hit the like and to share it out to people that you know, all that stuff. And I don't usually say those things, right? Because, it's not my focus, but I'm not so naive to think that I don't want my channel to grow, because I do. I mean, why else, it would be ridiculous to say, hey, I don't want my channel to grow, that kind of thing. So just to put that in perspective, that's why I don't typically say that, but I think I need to say at least once a stream, because sometimes, guys, I know I forget to hit the like sometimes. Matter of fact, I find myself going back to the video when I realize I didn't leave a like. So I do that on other people's channel, right? But yeah, so if you could do that for me, that'd be great. Anyway, geomagnetic unrest, okay? They're talking about that here too, what I just spoke about. And they still are forecasting a G1 storm. All right? But again, what was the main effect of what we've seen from all these CME impacts? Well, they go into that in detail here on spaceweather.com. And I'm not going to read the article to you. Again, please go check them out. They're in my description. But this is one of the photographs, and I'm only going to leave this here for a second. Okay? But this was in South Dakota. So it did sneak down into our northern states. Okay? Anybody that lives over here in the U.S. That's a sunflower field. Just look at that stuff, man. That is just so cool with me. But anyway, I'm not going to leave that on there. I want you to please go over there and give these guys some love. Who took this pic? I want to give this guy some, Elon Gain is his name. So yeah, please go check him out. Go over and check out the guy the Aurora photographer here. You can click on this picture. It'll take you to and show you a few more that he's done, I think. But it was just beautiful stuff. So, and they're calling it Helenius. I'm not sure how to pronounce that. Helenius Borealis. I guess it says at least 3 CMEs has hit, and again, it was just enough to actually push some pretty decent Aurora, because they just kept coming. So, but they did come down into the northern parts of the states. So, for just kind of clarify that. And I'm sorry I haven't even really looked at the chat either. So I'm going to keep moving, guys, and then I'll talk to you guys when I get done with this, okay? But another reason, guys, anybody that's watched me for any length of time know that this is the solar wind data, or space weather data, I should say. And we look at the BZ, we look for -6, and that's the angle of our magnetic field. And when it's in a negative position, especially -6 or greater, we're in a position to where space weather comes in a lot easier. So we'll take a little bit harder hit, more stuff kind of gets into our system to keep it simplistic. But when this shows purple here, that's -6 or bigger. Now, if we were to go back, which actually I can do that. Hold on a second. Let me just do that real quick. Okay, we'll go back 3 days. And what this is going to do is going to give us a 3-day time. And you're going to see the impacts, these CMEs. Okay, you see the CMEs hitting? Right? But notice that when we got down into -6, we weren't there for very long. So that is that's one of the biggest reasons we didn't see greater storm levels. So yeah, and I do have I want to show you this because I was looking at the magnetosphere tool. Let me find it here. Here it is. You can actually watch, if you hear me talk about negative and positive direction, you can actually see our magnetic field, our magnetopoles and everything tilting. Now watch, this is a side cut over here on the right. So watch what happens. Okay, so we start, see the angle here? And this isn't like really drastic. I'm just showing it to you guys so you can understand what I'm talking about with the tilt here. And so you see this kind of tilt this direction. Watch what happens at the end of it. Now we're pretty much straight on. That's what I'm talking about. Okay, so if the sun is here, right where my cursor is, and it's sending us space weather, we're dead on with it right now. Our magnetic field would be like facing it directly. This is our North Pole. Remember, space weather comes in easier on the north and south. So as I move this, go back to the beginning here, this is where we're at now, but if I go here, what happened? Now instead of our North Pole facing straight up, and I'm talking magnetic north here, guys, okay? We're now at this angle. So what did that do? Well, we're now pointed in the direction of the sun, the direction that the space weather's coming at us. So it gets in easier. More of it gets in. That's why. You can see it over here really well. See this? And this is a top-down view. This is the side cut. This is showing you, basically trying to show you left, right, if dusk, dawn is how they word it here. Right? But watch, that thing even moves. Watch. See how it kind of went back to more of a this angle? But it still is kind of still tilted towards the dusk side, which would be to the left if you're looking at the sun, right? But I just thought I wanted to explain that because I know that can be very confusing when I'm talking about that BZ. That's what I'm talking about, guys. When we're talking about the BZ, that's why it's important. When it gets in a southerly orientation, that means that we're pointed this way. And then what happens there is, again, our magnetic north is more directed towards the sun when that happens. So that's why that works like that. Now we have a natural tilt anyway that direction, depending on what season you're in. Okay? So, yeah. Anyway. Hope you guys understood that. I didn't want to like rush through that, but I didn't want to, take too much time talking about that. I've talked about it before, but probably not to what I just did there. Take this back to 1 day. But I get a lot of questions on that, guys. Okay. So yeah. Okay. Aurora, this is what we can expect right now. This is northern, this is southern. And I look for this to, you can see how it kind of pumps up and all that. And I've shown you guys this multiple times. But again, this will probably start to increase if we do start seeing another CME impact. But yeah. miss here? Okay. All right. So what do we got coming right now? Well, things are still happening. Like I said, we got more CMEs here. And that's what's going on here. This is on LASCO C2 on the Soho Observatory. It's about 1 million miles closer to the sun. Always looks at the sun, but it orbits with us around the sun. If that makes any sense. You can Google Soho, and you'll be able to see exactly where it's sitting. And you might get a better understanding that way. But you can see that we're still erupting. Okay, now these doesn't look like they're coming right at us. It's hard to tell, but if you keep in mind that we have this sunspot now facing directly at us, so if this thing starts to erupt, what would be different is that this one down here obviously is in the southern hemisphere. This one would be in the northern. So if this one here starts to like really act up, you know, we could be looking at some different stuff here, guys. So, and I'm not saying that that's going to happen. I'm just saying it's a possibility. So if we go back a day, look at the 20th. Again, you're seeing a few eruptions here. Again, most of them are not coming our direction. This was really the last active day that I've seen, really active. And that was back on the 19th. Okay. And these seem to be a little bit more condensed. And a lot of times when you see these condensed ones, if those things were to actually hit, they have to be a little bit more precise, right? But it also makes them a little bit more powerful because the plasma is really, really dense. It's all compacted into one smaller area. So, but yeah. Okay. This is the 304 angstrom. And again, guys, I'm not going to spend a whole lot of time on that. There's that sunspot again. This is the one over here that was causing all the issues. And let's go. Oops, sorry. And this right here is the one I like to show you guys when we're talking about the complexity of the sunspots. Remember, I see here that that's the one that was causing all the problems. Remember, the negative was intermixing with the positive. Negative, positive here, right? And when that happens, it makes it very complex. It's part of the complexity of the sunspot overall. And when the negative and positive get really close to each other, that's when you see flares. Okay? So even though you get a huge sunspot, you may not get any flares out of it if its orientation is the right way. If its signatures are, you know, stretched out further apart, well, kind of like this one. Okay, you see the negative here and the positive part of that's way over here. If this was sitting right in the middle, you know, we start getting flares. But this is the one that we're watching now. So let's take a better look at that real quick. Okay, let's see what it does. I haven't even looked at this yet, this part of this yet. Oh, I was wrong. I thought that was the sunspot. There's the sunspot. This thing just snuck up out of nowhere. You know what's crazy, guys? And I hadn't even seen that yet. Check this out. This sunspot here wasn't on the sun either until it was right here. There was no sunspot there. If you remember when this all started, it just kind of appeared and like immediately started flaring. This one seems to be doing the same thing. Let's find out. Let's see. That's not the sunspot I'm talking about. I thought it was, but watch. See this? See how fast that developed? And why did it flare? What was I just talking about? Look, you got positive and negative like really close to each other. That thing's still growing, okay? We're going to have to watch that one. It is interesting that it happened pretty much the same on the longitudinal line of the sun, northern and southern hemisphere of it. Both those sunspots appeared in that area. That's interesting. Wow. Okay, but anyway, yeah, you can see how it's still kind of, it looks to be like it might be trying to stretch out a little bit, which would make it more stable. But again, it is pretty complex already, look. And that's some pretty deep positive magnetism right there also. And you also got this yellow right next to the blue. Yellow and red are positive, so I mean, that's probably why it's flaring right there. You know, and to put that in perspective, I guess we could back this up some and look at a different spot, and I'll show you. See how this is over here and this, the negative's way over here? So, yeah, that's probably why, guys. Anyway, we'll have to watch that one for sure. So, the 211 angstrom here, you can see that, you know, again, we got still got things firing off. Things are blowing around here. We do have some coronal holes, but these are kind of off the edge there. Now, that little shadow you seen there, please don't freak out over that. I get so many people get upset about that, and they legitimately are kind of fearful. And I don't, you know, I've tried to explain that a lot of times, that little shadow. And what that is it's just it's the eclipse of the satellite. Okay? Basically, the Earth gets in between the sun and the satellite. The Earth's actually eclipsing the satellite. Okay? Notice how it doesn't stay there very long, and you see it kind of do that. That's because of the orbit of the satellite. Okay? So just understand that. That's something we expect. They will tell you when it's going to happen a year before it does. It's they forecast it. It's very easy to forecast. So anyway, let's back this up to that. Got here. Okay, we'll talk about that in just a second. I do want to bring this up. Okay, this is the South Atlantic anomaly. This helps people understand how our magnetic field is changing. Okay, we've always had the South Atlantic anomaly, which is a weak spot, and magnetics are different down here, right? It's down here over top of South America, and this is a 1980 field intensity, overall magnetic field intensity here. Right? So you look at the South Atlantic anomaly here, and you fast forward to what it's forecasted to look like in 2025, which it looks very close to that now already. Look what's happened. You see the intensity has increased right here? Well, lack of intensity. There's less protection here. Something else that we've talked about is it's split. You see how you got two different ones? And the overall area is bigger. So this is all pointing towards a change in our magnetic field. That's just simple as that. All right, and we talked about this for a minute, but not a whole lot. But it's important to understand this, because it's a marker for us to look at to see how healthy our magnetic field actually is. And as we move towards a magnetic either excursion or a pole flip, a full pole flip, regardless of which one ever happens, it's really typically, you can think of it as the same thing. The result is pretty much the same. Okay? But I'm not going to go into details on that either. Ben over at Suspicious Observers, he talks about the excursion events. So yeah, go check that out over there. But yeah, so let's see here. What's next? Okay. Well, I tell you what we'll do here. All right. I don't usually even look at this. I don't even know why I looked at it today. This is the buoy model. What these are, guys, these are weather buoys that are out here in the oceans that they put them there. They're basically, one of their main missions are to detect tsunamis. So, first thing I did was I went over here to the earthquake map. I didn't see anything, right? Nothing too big. You got like a 5 up here. And nothing really huge is happening on the earthquake front. But I clicked on the buoy map here, and we have a buoy off the coast of Australia here in event mode. I was like, man, that's kind of strange. So I was looking at it, and that's when I went back over here to the earthquakes. There are no earthquakes over here that would do that, right? And then I thought, well, sometimes if there's a hurricane or something like that, those things can do that. So I go over here and I look at windy.com. There are no storms over here. So what is going on with that? Now, there could be a technical issue. I'm going to say that straight up front, okay? I don't know. But what I can do is show you what the buoy event. You can just click on it. If you guys go over here, and it's going to show you this, and they're talking about wave height and a lot of different data points here. But if you see this as event detail, just click on that, and it'll take you to why it's in event mode. Now, the first thing I seen when I went over here was right here, okay? It says NDVC added additional data to its drift file. I'm not going to go into detail what that means, but they made a change to some of this stuff on August 17th. So I was like, well, what changed? So you can click here, and you click there, and what they did was they didn't change any of the stuff that was already there. All they did was add a couple, 3 more different data collection points. They're looking at, dew points and stuff like that now. This buoy is set up now, and it's relaying data back to the collection. Sorry about that, guys. I had real life going on. Got distracted there for a second. But yeah, you got 3 different data points here that weren't there to begin with. They added these. I don't think this has anything to do with why it's in event mode. Because number one, that's what, 4 days ago. Number 2, they just added. They didn't take anything away or make some big, massive change to the rest of it. So I don't know. I don't know why we're seeing this, but if you just back that up there, and we can go here and actually look at some of the stuff, why it's in event mode. You see this little red line here? That section of time is highlighted here. And I don't know much about these buoys, guys. You guys can go look at the data, but it does look like it had a significant drop in wave height. And I don't know why it did that. And it looked like it continued to, go that direction. So whether the buoys is having technical issues or not, it thinks that this is what's happening. And I don't have any way to say, hey, this is actually happening or not. One thing I will say, let me go back here, is that the other buoys around it, of course, they're red. See the red? See, if there was a yellow one, if this one was yellow, kind of just hanging out, I wouldn't even probably be talking about this. But because this is red, and what that red means, if you look at the key, here, okay, the yellow ones are stations with recent data. In other words, they're working. When they go into event mode, it says tsunami stations in event mode. In other words, it's detecting something that isn't normal. But the red boxes are stations with no data in the last 8 hours. So that particular, this buoy here is not working. Neither are all these, right? So I didn't have anything to compare it to. So we got a buoy out here in event mode. For what reason, I have no idea. But it, and I showed you the details on it. So I don't think there's any kind of tsunami or anything like that, guys. I'm not saying that. I'm just saying we have an event mode on this buoy. There might have been, I think we've seen like cracks open up on the ocean floor, and sometimes you'll have a pretty decent drop. And again, there's probably a good chance that this buoy's got something wrong with it. Okay. And given the fact that they did make some changes, it would make sense for that to happen. But I wanted to show it to you and give you guys both sides of that. I just simply don't have a good answer for you when it comes to if that's actually what's happening or not. I just found it really, really interesting. Something else here, guys. I want to show you guys something, and I'm only bringing this up because I got 2 more emails about this, and I don't know why I keep getting emails on this. I get people telling me that they would send me stuff and say, hey, why are we seeing storm systems spinning opposite directions from one another right next to each other? And they would send me a capture of like this right here. Okay, and they would point out to me that, you see the directions that things are moving. This is windy.com, by the way. So that's the northern hemisphere, and that's turning right. This is the northern hemisphere, well, I should say clockwise. This is the northern hemisphere, and right next to it, it's moving counterclockwise, right? And they were wondering that shouldn't happen, is what they were saying. Well, but it's not correct, guys. Okay, and let me show you why. Notice that there are no low and high pressure markers on this map, because I think this is what's going on. I think people are looking at this thing and they're not turning on the low and high pressure. That is what causes storm direction and the rotation of our planet. Okay, that's what the rotation of our planet and the low and high pressure is what causes storms to spin a certain direction. And they're going to spin opposite in the northern hemisphere and the southern hemisphere. And most of us understand that already. But I understand that there's a question, why are we seeing storm systems spinning opposite directions right next to each other? Well, how is that possible? Well, this is why. Let me show you. Let's go here. Man, where's it at? I was trying to put the pressure back on there. Let's see here. Sorry about that, guys. I thought I had, there it is. Okay, so now you got high pressure, now you got the pressure turned on. Now look what's going on here. Do you see this? That's a high pressure, northern hemisphere, turning right. That's a low pressure, and it's turning the opposite direction. This is why this happens. Okay? You can go to any storm system on the planet right now and look at it. If they're spinning opposite directions of one another, one of them will be low pressure and one of them will be high pressure. That is a fact. Okay? And I can show you why that is. Essentially, with one low or high pressure, one of them's getting drawn in and pushed out, and the other one's getting drawn in and pushed up. And that causes that spin because of our rotation. So it changes the direction. You know, and also, guys, you know, and I bring this up for like hurricane season anyway. This is important to know in hurricane season. Because, you know, we don't get hurricanes that cross over the equator line. It kills the hurricane. This is why. Okay? So, and notice that this high pressure here is in the northern hemisphere and it's turning right, right? This high pressure, or clockwise. This high pressure down here is spinning what direction? Counterclockwise. Imagine that. Right? And then if you find a low pressure, guess what? It's doing exactly what it's supposed to do. Just saying. So I just wanted to clarify that again. I've done this a lot, and I really don't understand why keep getting emails on that. And I can see how it could be confusing for some people, but this isn't really even about space weather. This is kind of like just typical weather patterns. That right there, you know, that's like 8th grade science stuff. Really is. Maybe even before that. And I get forgetting that stuff once you get out of school, right? I mean, I'm not saying any of that. I just want people to understand that if people are telling you that this is wrong, right? Then what's going to happen here, guys? And I've seen this happen. They're going to show you this. And then the next thing that they're going to tell you is, well, look at these two storms right next to each other spinning opposite directions. But what they won't do is this. They won't do that because they can't explain that. That's why. Okay? It's seriously. So if somebody's just showing you this stuff and saying that that's actually going on, ask them to turn the pressures on. That's what I would do. So, yeah. And I can show you more in depth why low and high pressure do this, right? And I've done it before. So, you know, I'm not going to take the time to do it now. But just like I said, just real quick, just if they do that, if somebody tells you that this isn't normal, then ask them to put the pressures on. Click the pressure button and let's look at it. Because everywhere on the planet right here, you can go to it and you can see that everything here is spinning the exact direction that it's supposed to. Okay? And I'm not, I'm not trying to like pick on that kind of a thing. It just, I've explained it a lot and I still get emails on it. And I think a lot of it's from people, newer people that haven't really, dove into this yet. And I'm happy to explain it. I really am. My biggest thing here is, guys, if somebody, again, shows you and tells you the storms are spinning in the wrong direction and this is the map they give you, ask them to give you this map. Okay? And then when they then ask them to explain why the opposite low and high pressure are spinning opposite directions of one another. So everywhere they're saying that it's doing something wrong, it's because the high and low pressure are next to each other. That's the answer to the question, guys. So anyway, not going to sit there and beat a dead horse anymore. But yeah, guys, so, I wouldn't freak out about this buoy. I just wanted to show it to you guys, right? And again, if there was something big going on over here, we'd already know it, especially if it's been in event mode for any length of time. Actually, I wonder when that did go in. I didn't look at that. What time is that? Huh. That, like, legitimately just happened. Okay. Well, we're going to have to keep an eye on that, because seriously, that just happened. Let's go to the earthquake map again. Let's check that real quick. I'm not seeing anything. The only thing I can see is this one. But, you got islands and stuff here in between that and the buoy. So I don't think anything I'm seeing here on the earthquake map can explain why that buoy's in event mode. Yeah, there is a lot of buoys turned off, Nana, for sure. 100 for sure. I think there's more turned off than there are on. Yeah. But you can see, we'll look at the global picture here. See them? There's a bunch of them. There are more turned on than there are off, but there are a lot that are off. And a lot of them, they break, they go bad, they get shut off for whatever reason. I don't have an answer for you on that one. So, but just wanted to, bring that to you guys. We'll keep an eye on this because, yeah, I mean, it just happened and it is kind of odd. Now, again, I will say this, that most likely that's probably a technical thing. And I showed you why, because they did do some upgrades to it. And sometimes when they do that, it can get some software issues or what have you, and it could cause it to do things like that. So just want to point it out and have us all keep an eye on it. So, but anyway, guys, that's all I got for you. I hope that, I'm sorry I didn't give you guys a live stream the other day or yesterday. There just wasn't much going on, but I did want to come on here after pretty much the event we were talking about for a week was pretty much over, and I wanted to show you guys what exactly happened. So essentially what happened was the CMEs did hit, and again, I'll show them to you right here. It's just our BZ didn't get down to -6 or bigger very often, so we were able to fend it off fairly well, and they kind of sailed a little more to the south than what we thought they were going to, at least for myself, right? They still impacted, because you can see them. They just didn't end up being as strong as what they could have been. But we do have another flare player, like I said, guys, so we're going to keep an eye on this. And so, yeah. So I'm going to say hi to everybody real quick, and then we're going to get on off of here. Let me just bring this up. Pop this out. Okie dokie. What's up? Hey, Leisure, hope you're feeling better, bud. Hey, man, what's up? What's up, Tommy? Tinfoil hat, what's up? Russ, what's going on, man? Aloha. Heck yeah. Blue Dazzle, what's happening? Seen you over on the boat tonight. Hey, that was a great show tonight, wasn't it, Blue? Really was, wasn't it? Tommy, you killed it tonight, man. I'm not kidding you. You really did. It was a very good show. Hey, Miss Hermit, hope you made it home. Hey, Jennifer, seen you over here too. Hey, Keith, what's up? New England Dirt Roadie. Yes. Great question there, New England Dirt Roadie. He asked, is it possible for events to have psychological effects on the brain? Yes. There are so many things that happen to us physically during these kinds of events. Okay, and I can't go into all of them because there are just so many of them, but they are directly tied to this. Okay, doctors now look at space weather, guys, believe it or not. Like when they're like going to schedule heart surgeries and stuff, they really do take this in consideration now. So keep that in mind. Doctors are doing this now. So we have to 100% all the time keep that, you know, in the forefront there of our minds, and kind of try to understand that. What did I do? I mean, I popped that stupid chat back, didn't I? Okay, let's bring it back out of here. Sorry about that. I'm not sure if you guys can even see that. I don't think you can. Let me yeah, okay. So we'll go over here and let's go do this real quick. Okay, so there you go. I got you guys back now. All right. So yeah, it does. So guys, if you guys have family members, or if you're sick yourself, please take that in consideration. And I would, you know, people will ask, well, how can that affect, you know, our heart and stuff? Well, back in the day, guys, I'm not sure if you remember this or not, but when somebody would have a pacemaker put in, because this happened to my grandpa. He wasn't allowed to be next to a microwave. Okay? Why? Because of the magnetism that's involved. And it could have messed with his pacemaker. So the same thing applies to us in a larger scale when we're getting hit with space weather. It can mess with us. So, and I'm, you know, and depending on what's going on and depending who you are and what kind of issues you've had, that would definitely be dependent on all that. So if you think you're having issues, then please go talk to your doctor. Yeah, I would agree with that, Mimi. I really would. Earth's magnetic field is decreasing. Yeah, I mean, I don't think anybody really even questions that anymore. That is something that is it's just a simple fact. Everything is showing it. All the data shows it. Now, why it's happening, that's where the argument everybody starts fighting about it, which I refuse to do. I simply don't care. You know, to be honest with you, I don't care who's right or wrong. I just want to look at the data and try to figure it out. You know what I'm saying? I've been wrong many a times. And like I said, you know, in my last video, guys, I you know, I could have just shut up about where I made a mistake. I didn't, though. I came straight back out here and told you. And, you know, it wasn't a huge mistake. It was just basically, ended up being kind of semantical. But I did need to explain what I was talking about. Right? So I wanted people to understand that the cannibal CME isn't really one CME eating another. And I should have, you know, I knew that wasn't the actual case. I should have just went more into detail and told everybody that. Because when that happens, when one CME catches up with another, the density gets smashed in between two of them. One don't eat the other. Okay? So that's, you know, and I should have clarified. That was a term that was dubbed, I don't know, a few years back, and everybody kind of grabbed hold of it because it is a cool term. You know, cannibal CME. Sounds really cool, right? Yeah, there you go, Tommy. Me too, man. Yeah. Yep, I got you, man. For sure. But yeah, guys, I mean, I really, you know, when I make mistakes, I like to come out here and tell everybody about it because I don't have no shame or regret on that kind of stuff. I'm able to be corrected. I take respectful criticism and I try to apply it to what I do. And I would be so happy if the rest of the internet would do the same thing, because it does no good to start pointing fingers, who's right, who's wrong. At the end of the day, does that help you solve the problem? No, it doesn't. You need to move on from that and look at what was wrong and how people got it wrong, not who got it wrong. Because that has nothing to do with you trying to solve what's actually going on. So leave the who out of it. That's all I'm saying. That's why you never see, I disagree with a lot of people, right? My own opinions, but I don't come out here and start attacking people. Ain't gonna happen. Ever. Promise. But anyway, guys, check out everybody I tell you about. Mark Pires, Marth, the Lifeboat, everybody, and everybody from over at Paul Bagley's channel. Go check them all out, guys. Again, the excursion thing was brought up. Go check out Suspicious Observer. He talks about that over there. Anybody else, guys, if Scott starts making videos again, which I hope he does, Planet X News, go check that out. Go check out Matthew Shipley. Guys, he's got a 24-hour feed, and he upgraded to fiber optics. Okay? So he's got like extremely high-def pics of the sun. And as a matter of fact, guess what? We're going to go look at that real quick before I get you off here. Okay? So hang on here just for a second. And we'll get you there, okay? It only take me a second to get you there, guys. Let me back that off a little bit. Say Matthew Shipley right here. Dude knows what he's talking about, and he has an awesome live stream 24 hours a day. And if something happens, he'll come on and do some explaining on what's going on. But this is, he's got all these data, all this data stuff here, all these models, he shows them. But let me take you back a little bit in time here, just to give you guys a picture of the sun, what he's got with that. There it was. Okay? This is what you're going to get to see. Okay? So if you pop over here and you do this, this is what you're going to see. Right? I mean, ain't that freaking cool? I mean, this dude does a good job with this, man. Matthew Shipley is awesome. Sorry, I didn't mean to call you a dude, man. I don't like doing that. I just think it's, yeah. Anyway, I respect what you do, Matthew. Guys, everybody, please come out here and get it. Look what he did here with the CMEs. See this? Look at the modeling here. The graphics here. He's killing it, guys. I'm telling you. It's awesome. I mean, I can't say anything more. Go check out Rip's channel too. Ripper over there. Anybody want to talk about prepping, all that stuff, go check out Rip. But this is a really cool, he does a really good job over here. He was down for a couple weeks because he was upgrading to fiber optics. Plus he's got this little cool little astronaut dude up here. Check him out. Right there. Floating through space. I like it when people can add a little fun to it. You know what I mean? But go check out Matthew Shipley, guys. You won't be sorry. See, they're showing that eruption again. He's going through all the angstroms. I mean, all of it's here. And if something big happens, he does typically pop on for like 10 or 15 minutes and talk about it. So we'll give him some love, He's got 3,301, roughly 3,300 subscribers. Let's try to get him at least an extra 100 here. I mean, I think you guys could do that, couldn't you? It'd be awesome. And yeah, the Lifeboat also. Do me a favor, go over there and check that out too, guys. Come on. I say it every stream. You guys know I do. So yeah, and the link to the Lifeboat is in the description, guys. So, but yeah, I just think Matthew does a really good job over here. Spaceletter.com. Check them out. Check out everybody. You know the easiest way for me to explain this, and I'm just going to just show it to you real quick. Come over here to my subscription list. Everybody I subscribe to, the majority of the people that I watch and look at, are all right here. I don't hide my subscription list like a lot of people do. You want to know why people hide their subscription lists? Because they don't want people to know who they're watching. And I get it to some extent. But I'm not afraid to watch somebody's channel that has either attacked me or had disagreements with what I've said. I don't care. I still watch their channel. I don't really care. So if you guys, and right here, like Max, Max Velocity. This dude has got his weather game on point. He's a younger kid. Go give him some love. He does a great job. Anytime there's any kind of weather events, he's on here live streaming for hours. Ryan Hall, the same thing. Okay? Go check him out. This guy is killing it. He's got a huge team of people. They go out and storm chase. They chase snow. They chase floods. They chase hurricanes. I mean, he used to be a newscaster, but now he's here on YouTube. Awesome dude. Guy lives in Kentucky. But yeah, go check him out, guys. Easiest way to know who I watch is to go to my subscription list. Because guess what? It's there. So, but you know how it go. Yay. Anyway, guys, God bless. Well, let me get you back over here for a second. All right. God bless. Yahusha saves, and you can drink this Kool-Aid.